What you're seeing right now is not some cheap magic trick. It's simply science. And you're probably wondering, what is happening here? How is that object floating? Well, let me explain. Hi, my name is Hiba, and today I shall be your guide through the journey of discovering superconductivity. Now, this journey starts in the beginning of the 20th century. Back then, we knew that resistance was the tendency of a material to oppose the electron's flow. We also knew that the resistance of a conductor increased with temperature. We could prove this by doing our own experiments. So here we have a multimeter. I'm going to use it to measure the resistance of this copper wire. As you can see right now, the screen is displaying 0.6, meaning that the resistance is roughly 120 ohms. Now let's heat up the wire and see what happens. As you can see, as the temperature of the wire goes up, its resistance also goes up. To make things simpler, let's draw a graph representing our experimental results. We would get something like this. What would happen to the resistance if we kept dropping the temperature? Would it eventually reach zero? Maybe reach substable resistance or even start rising again? So in 1911, we finally had the answers to these questions, when Dutch physicist Heikki Kamelin Onnes cooled mercury down while simultaneously checking its resistance. What he found was groundbreaking. So when mercury reached 3 degrees Kelvin, its resistance suddenly dropped to zero. That was the birth of the very first superconductor. Now, you guessed it, superconductors are materials that, when cooled below a certain temperature called critical temperature, have zero electrical resistance, meaning that a flow of electrons can move through them without colliding with each other, and therefore without losing energy. They also have another property called the Meissner effect, which allows them to expel magnetic fields and therefore flow over magnets. Now I know this is all pretty cool and exciting, but most superconductors known today only work under very low temperatures. So that's a major drawback that severely limits their practical uses. But fear not, new research done in October 2020 in the University of Rochester was able to produce the very first room temperature superconductor. But there's a catch. Although it works at 10 degrees Celsius, it only has superconducting abilities at very extreme pressures. So we're not quite there yet. But the discovery is new and the possibilities are endless. This may be just the tip of the iceberg of a broader set of discoveries. And who knows, maybe this is the start of a revolution in the world of electronics.